Good afternoon. My name is Fabrice Drouin, and I work with Async, and we're one of the companies working on building and deploying Lightning. And I'm going to talk about what happens, what was the process of bootstrapping and developing Lightning, and what we've learned since we've been on mainnet. So, who doesn't know what Lightning is? Okay, and who has used Lightning? Who has actually used Lightning? Okay, so it's almost everyone, so, which is good. So Lightning is basically an evolution on the idea of payment channels. It's an old idea. I think it's even older than 2013. I think it started in 2011. But the first big step for Lightning was the Lightning Network paper published in 2015 by Joseph Poon and Taj Dryja. And a very important milestone was a series of articles published by Rusty Russell also in 2015 on how to go from a very interesting concept into something that could be actually implemented. So Lightning started as basically independent implementations in 2015, and in 2016 something really important happened in Milan. We decided to go for an open source process, an open source RFC-like process, and instead of having Lightning driven by a group or a specific company, Lightning is first a process to build an open source specification that is detailed enough so that anyone just with the specs and the test vectors can implement Lightning. So it is very important, because I do believe that Lightning got a lot of interest because of that structure, of the fact that there was not one single company behind. There is no doubt as was to what we try to achieve. There is no ICO or token. It's an open source specification that is very detailed, that includes everything you need to implement it yourself. And there's also, each company is building its own implementation. So you have 3 of them now. There are other people working on other Lightning implementations, at least 2 of them. There's a team in Japan. There's people working on a Python implementation. There's work being done on Lit at the MIT. So that structure of Lightning is, I think, part of what is so successful. Not the technical merits, but also the open spec organization. We made the first real payment with Lightning actually it was on Litecoin, not on Bitcoin, because we just couldn't wait for Segwit to be activated, so we decided to do something and make a real payment on Litecoin because it had Segwit at the time. The specs reached version 1 release candidates in December, and right now you have all three major implementations are live on mainnet. So the specs, the low-level specs, it covers everything: the binary message format, the transport layers, the transactions, the Bitcoin transactions, the onion routing, the encryption, and the invoice protocol. So it's fairly complete and detailed enough so that you can have a good idea of how it is and how it works just by looking at the specs. So the idea of Lightning, I think everybody knows. You have one transaction to open channels. That's the funding transaction on the top. It is published on the blockchain, and then each party, Alice and Bob in this case, they will exchange messages and they will update a transaction. We call it a commit transaction. That is valid. It's a valid Bitcoin transaction, but it's not published. So that's what Lightning is about: updating a Bitcoin transaction that is valid, but that you don't publish. And that's the basis of most layer 2 protocols. You update Bitcoin transactions that you don't publish. And at the bottom, you see the closing transaction. Suppose that you're happy with the balance on your channel and you want to close it and go back to the blockchain. Alice and Bob agree on a final transaction, and they get their money back on the blockchain. So that's how Lightning works. Basically, you update a transaction that splits how to spend the money in the opening transaction. So in this case, when it was opened by Alice, at the beginning Alice had 10 bitcoins and Bob had nothing, and then later on Alice has 3 bitcoins and Bob 7. And when they close, Alice has 4 bitcoins and Bob has 6 bitcoins. And what you will see on the blockchain is the first transaction and the last one, and everything else will not appear on the blockchain. It's between Alice and Bob. And from a user's point of view, that's what it looks like. So I guess most of you have tried, but basically it looks a bit like Bitcoin. You have a QR code, you scan it. The QR code includes an amount, a destination, and a payment hash. And your wallet will compute the routes to the destination, create a packet that will be forwarded to the nodes on the route. It will reach the destination. It will see that it's a pending request for them. It will check the payment hash, send back a pre-image, and that's it. And you've paid. And this is almost instant. So for those of you who have used Lightning, this can happen realistically in 1 or 2 seconds. So you really get instant payments. You don't need to worry about getting transactions to confirm. And it works with really small amounts. So the first phase for us was to test Lightning on Testnet. And the tests were very positive because we could validate the low-level stuff on the specs, transport layers, the encryption stuff, the way we built transactions. We could iron out compatibility issues between implementations. We could also, each team could validate their own implementation choices, because something I forgot to mention that is very important with Lightning that you don't have with Bitcoin. It is possible and actually good to have different implementations. So for Bitcoin, it's still an open question. Is it good to have multiple Bitcoin clients? Some people say yes, some people say no, because Bitcoin is a global consensus protocol. So clients must all reach exactly the same results, all of them, all the time, and it's really, really difficult. Lightning is very different. What happens is more traditional client-server communication. So the exchange you have with your peers have no impact on the rest of the network. So it is fairly easy to have multiple implementations, and if something doesn't work, it is very easy to upgrade. And we've done it many times on the Lightning Network, on Testnet, on mainnet. So there are no global consensus issues that make it look like upgrading is like changing a wheel on a moving car. It's not like this. It's very easy, and we do it all the time. So it's very possible to have completely different implementations on Lightning, and they are completely different. One of them is in C, one of them in Go, we have something in Scala, and people are working on Python stuff, and it all works together. So Testnet showed that what we had was good from a low-level point of view. The protocol was good, and it could actually work together. So you have different tools that were built by other people. You have an Explorer, you have yours, where you can read articles for a small payment. I think it's just a few cents, and you can read stuff. But we also saw on Testnet, and I think it's true for most Bitcoin projects, that a lot of bugs were not reported. A lot of nodes were unreliable, as in people were really anxious to get their nodes on the Explorers, but very often they forgot to open the ports so that you could not reach the nodes in the first place. A lot of these nodes were offline most of the time and could not relay payments. And so Testnet for Lightning is much less reliable than Lightning on mainnet because of that, because most of the nodes on Testnet, they're offline most of the time, which is a bit frustrating. So after a while, it was really time for us to take the training wheels off, and the first one to do that was Blockstream. So Reckless at last, Lightning on mainnet. So all 3 implementations were running on mainnet in April of this year, and we could all start buying stickers. So who bought stickers with Lightning? Yeah, okay, quite a lot of people. But we saw a few, as things progressed on mainnet, we saw a few operational issues. None of them are very important, and there's solutions for most of them, but it's what we saw during the first month of testing. There's one that we knew from the beginning. It's a lack of symmetry in payment capacity. So what it means is, if Alice opens a channel to Squeaky Clean, that's a Lightning node, and if Bob also opens a channel to Squeaky Clean, do you think that Alice can pay Bob? Who thinks Alice can pay Bob? Who thinks Alice cannot pay Bob? Okay, so Alice cannot pay Bob, because what you get is this. Alice has all the money on her side, and Bob has all the money on his side, and Alice cannot pay Bob. Bob cannot receive money. So this is because when you create a funding transactions, all the money is added by only one of the parties opening the channel. So there's a really good long-term solution for this. We call it dual funding, but it was too late to make it in the specs. There's also re-anchoring that could solve the problem. Re-anchoring is just replacing the funding transaction by something else. And this could work very well with channel factories, where the closing of a channel could be also the opening of new ones. And there's also something that could be done today. So the really basic solution is when Alice opens a channel to Bob, Bob also opens a channel with Alice. So that's the poor man's dual funding. So there's nothing to add to the specs. What could be done too is use a field when you open a channel. We call it push. So when I open the channel, I push some money to the other side, and so the channel can be used on both directions. It requires an external setup, because when I open the channel, I need some kind of ID that I can use to say to Bob, okay, this is my ID, you already have money that is mine, so I'll push it to you. Actually, we spoke about fees in the previous talk, but the biggest operational issue we had on Lightning, on mainnet, was fee management, on-chain fee management, because the idea of layer 2 solutions is to have transactions that are valid but not published. And valid means that the inputs that you're spending are still on the blockchain, that the transaction is signed properly. But it also means that the fees are realistic. And the fees, the on-chain fees, they are realistic. And on-chain fees change all the time. So in Lightning, right now, we have an update mechanism where peers can exchange the fee rate that they think is right. So if the fees go up, I can send a message to my peer and say, okay, I think that the fee on our commitment transaction should go up, and this is what I think is right. But that's a problem, because estimating on-chain fees is basically impossible. On-chain fees change all the time. They can change really quickly. So I saw once, when I was debugging these issues, fees going up by a factor 10 in just 3 minutes with the same estimator, and going down again after a few hours in just a few minutes. What it means is you will always get fee rate mismatch errors. And if you're strict on accepting fee rates, it means you're going to close channels very often. And that's something you've seen a lot. I don't know if I think it hit Bitrefeed probably, and hit everyone that was running nodes on mainnet. You could see on the IRC channels or on the Slacks, things like block X closed all my channels. What do I do now? And it's because a given block had increased on-chain fees a lot, and an update had been sent and refused, and the channel had been closed. So this is something for which we have short-term solutions and long-term solutions. There's also something really strange we all found out at different times. Do you know how much is 1,000 divided by 4? So it's a room full of scientists and mathematicians, so you should have the right answer, right? Yes. The answer is 253. So why is that? I won't go into the details, but it's a fun story. It's linked to the way estimators, the units used by fee estimators and by Bitcoin Core. So basically, on Lightning, our fee rate is in Satoshi per kilowatt. Most estimators and wallets will give you fees in Satoshi per kilobyte, and the relay fees, the limit is in Satoshis per virtual byte. Who knows what a virtual byte is? And Christian is still not raising his hand, and I'm not raising mine because I wish I didn't know. But okay, that's it's a funny issue we had that all of us had on Lightning. So 250 actually will get you transactions that cannot be relayed, so they're not valid. So it would be really nice if there was a way to remove fee management from Lightning and move it somewhere else. And the first thing that comes to mind, and I've made that mistakes, I don't know, maybe 5 times already, is use CPFP, but you childs pay for parents, which means when you have a transaction with really low fees, you publish one that spends it and with a higher fee. And it doesn't work because it's a chicken and egg problem with the way Lightning is built. You have to publish the first transaction in first place to use CPFP. But there's a very good solution, very elegant solution with L2 that will move fee management out of the protocol. So there's a very, very nice solution for this coming, I wouldn't say soon, but maybe next year. And the short-term solution is just to be really lax when you receive an update that you think is a bit too high or too low, and this is what we're doing now. Another challenge for us was how to build mobile nodes. To be really useful, to be really used by people, I think we need mobile wallets, mobile Lightning wallets, and it's hard to do. So you basically have 2 options. The first one is a remote control. So your wallet is remote controlled for a node that is running somewhere else, in the cloud or at home. It's an option that is used by, I think, Zap Wallet and maybe others. It's the easiest option, but there are security issues because basically what it means is you have a node somewhere that accepts incoming requests to send money. So it could be hacked. It's a bit of a problem. So there are people working on this, and we'd rather work on having real Lightning nodes on mobile phones. So there are many different issues. The first one, it's a bit trivial, but it's actually a bit of a problem. You need to find a framework that you can use on Android and potentially on iOS and other systems. You don't want to write everything from scratch on all systems, and it's not that easy because there are limitations on what you can use on Android or iOS, and there are very few frameworks that actually work everywhere. There are also operational issues because a mobile node will be offline most of the time, and you need to monitor the blockchain. That's what everyone is telling you about Lightning. There's a big problem. You need to watch the blockchain and do something if the other guy is trying to cheat. So how do you do that if you're offline most of the time? You also need to validate channels. When somebody tells you there's a channel there, you need to check that the opening transaction actually exists on the blockchain and has not been spent. And you need to synchronize your routing table. So I'll give you more detail on this, but basically right now we use a broadcast mechanism to broadcast the routing table to everyone. If you're offline, you will miss updates and your routing table will not be up to date. So that's a problem for offline node. The first problem is how to monitor the blockchain. And there's so this is what we did, on Lightning. Right now we use the JVM, we use Scala. Does anyone know what Scala is? Okay, almost no one. So in the Scala community, we call it the problem. Scala is not widely used, but it's a really nice language, and it runs on the JVM, so it runs on Android. But there's no way it can run on iOS right now. So the blockchain monitoring problem, there are 2 options. You delegate monitoring to someone else. That's what we call watchtowers. Or you do it on the device. Delegating monitoring to watchtowers is not really practical today because the idea of watchtowers is that they learn nothing about what you're doing. They don't even know which channels they're watching, and it's really hard to implement because you need to store a lot of data, and you never really know when you can safely delete it. So it's kind of a problem for the watchtower. Its data set is growing, and it does not know when to prune it. And on device, it's possible, but you would require a very long timeout. That is, the delay for you to react if somebody is trying to cheat would be very long because you're offline most of the time, which means you may have a 1-week timeout on your phone. What it means is if you have to close the channel because the other party is gone, then you will have to wait 1 week before you get your money back. So it's not very convenient. But there's another option. You just send money, you don't receive it. If all you do is sending money, you don't need to watch the blockchain, because every new state is better for you than the old one. So if someone wants to cheat and publish an old state, more money for you, so you don't have to care. And this way you can be offline for weeks and you're safe. And there's something else that is very important, I'll come back to it later, is that channels that you open from your phone don't have to be announced. So they don't have to be part of the routing table, and that's the default we'll be using on our Android wallet for months now. So obviously send only is limited, and we are working on it, and maybe we'll have good news for everyone very soon. But right now, we do think there's a good use case for send only mobile wallets, because they're very easy to implement. There are no security issues, and they don't clog the routing table. You still need to do a few things though, even if you don't have to monitor the blockchain and watch everything you need to handle closing transactions, and you need to watch your own funding transactions. And to do that, right now we watch the output script with Electrum servers, but it would be nice to be able to watch specific transaction IDs, and this is something that will be possible with client-side filters, what people call neutrino, or what other people call BIP 157 and 158. So this is something that will allow you to use transaction IDs as entries in your filters, and we will probably switch to client-side filters when it's available. Routing table management. So again, routing on Lightning is now done by having everyone know the entire routing table. So to do that, you send updates to the routing table to your peers, and you sort of keep an updated routing table at all times. It's fine when you're online most of the time, because your routing table is always up to date. But when you're offline, there's a problem. And the first implementation was really naive. When you start, you request everything from your peer, which means that you can't do anything for a few minutes, and it's a problem. There is now a much better synchronization mechanism in the specs, where you will just queries for the channels that you are missing, and there are even better long-term solutions with inverted Bloom lookup tables that will let you synchronize your routing table much faster than what is done today. So for those of you using Eclair, you may have noticed that when you started for the first time, if you've been offline for a few hours or a few days, for about 30 seconds, it doesn't work very well, and then it works. It's because of the synchronization issue with the routing table, and we are working to make this much faster. So, but now you have to wait about 20-30 seconds. So the watchtowers. So the idea of watchtowers is you delegate monitoring the blockchain to a trusted a third party, and you don't want them to learn too much about what you're doing. And there are different ideas on how to do this. One of the most elegant ideas is to encrypt what you want them to publish, and use the first 16 bytes of the commit transaction as and tell them to watch for a transaction that starts with this, and use the last 16 bytes as an encryption key to decrypt what you told them to publish. It's very elegant, and that way watchtowers learn nothing about what they're monitoring, but there's no incentive to do that. And you don't know when to delete data, so it's not very practical, and I don't think we'll see these type of watchtowers. You could probably do things if you remove the constraints that watchtowers don't know where they're watching. So if they know they are watching a specific channel, then there are things you can do to implement it, to make it easier to implement. But it opens you to a new attack vector. If I have a channel with you, and if I also manage to be your watchtower, then I can cheat easily, because I'm not going to punish myself. So it's not that easy to get right. So it would be really nice if for watchtowers you didn't have to remember all the old states, but you could just use the latest one. And the good news is that too will be possible with L2. So L2 will make building watchtowers much easier and much cheaper for the people who want to run them. So L2 is also really good news for this watchtower part. It will help people build mobile wallets. So routing on Lightning. So you may have heard that routing doesn't work. So there are different options. Some people say that it cannot work. We have to solve an impossible problem, blah, blah, blah. And other people say that it may work, but as the network grows, it will become impractical to work with the type of routing that we have today. And there are two concepts that are mixed up when it comes to routing in Lightning. There's a high-level concept. How do you find routes to your destination in a network? And there's also a low-level concept. How do you build and forward packets along the route? And Lightning defines precisely the low-level stuff. How do you, if I know where I want to send something, if I know all the hops I want to go through, then Lightning defines precisely the message and encryption you should use to make it to forward your message to the destination. But so it's onion routing, basically nodes that relay messages only know about the hops just before and just after them, but they don't know the origin or the final destinations of messages. Lightning does not really precisely define how you find routes between nodes. It's sort of not really in the protocol. So if you have a way, if you know that to send a message to someone you have to go through A, B, and C, then you can use what is in Lightning to send a packet. But not having everything defined in Lightning is actually not a problem. It's a good thing, because we may upgrade the way you find routes later if you find something better. So that's how onion routing works. Basically, when you relay something, all you know is who sent the message to you, who you're going to send it to. You don't know where it comes from. You don't know the sender, and you don't know the destination. So it has really good privacy properties. There's one thing though that is a bit limited. You know the pre-image. The pre-image is the same along all the hops. This is also something for which we have ways of blinding the payment pre-image so that it will change at each hop. So payment hash correlation will become harder with Lightning. Right now it's possible. There's one thing that is really hard though. So people say that if you are if you're the second node and the second to last node, basically you know what is going on because you're connected to the sender and you're connected to the destination, so you can correlate. But there's an open question for you. How do you know that you are the second node or that you're the second to last node? So I'll leave it as an open question. Routing table management. That's probably what people think is the big issue with Lightning. Everybody knows. Everybody knows the routing table, as to know the entire routing table right now. So nodes keep an up-to-date copy of the routing table, and it works very well with a few thousand nodes, but synchronization has been improved, so you can start and synchronize very quickly now. But we know it's not going to work with a few million nodes. But there's a trick. You don't have to announce all channels. And it's the case right now. When you look at explorers and you see nodes and channels, but you don't see everything. And it's impossible to tell, but I'm pretty sure that probably there are more hidden channels, or maybe at least as many hidden channels as public channels today. Like all the channels that you open with your phones, they don't show up on explorers. So only nodes and channels that relay payments have to be announced, and not even all of them. If you have 5 different nodes between A and B, you can just announce one of them, and when A receives a message, it can choose which one it wants to use to forward it to B, but it does not have to be a public channel. And terminal nodes, nodes that only send or receive money but do not relay payments, they don't need to be added to the routing table. So the mobile node, the personal nodes on laptops, there could be millions of them, and it would have no impact on Lightning today. And there's something else too. You can build hidden networks of unannounced channels. So you could do something on Lightning where you talk to people and you exchange out-of-band information on node information and channel information. You don't publish them, and you can build like virtual hidden Lightning networks that no one knows about. This is already possible today. So what you see on the explorers are the big blue, dark blue nodes, but actually there are many more of them, and you don't see them on the explorers. And it's not something that could work, it's how it works today. And the other thing we hear a lot is you can't send $100 on Lightning. And it's true. So why do you think you can't say $100 on Lightning? The first answer that comes to mind is because users open small channels. Okay, so why do users open small channels? It's because we told them to. So obviously it's not really surprising that now people are not completely reckless, and they kind of listen to what we say, which is surprising in the crypto world. And we told them to be a bit careful and not to open large channels. There are limitations in the specs as to the largest amount you can send, the largest amount you can put in a funding transaction. So people actually listen to us, and they don't open large channels. That's why obviously it's going to be very hard to send $100 or $200 through Lightning today, but it's because people are not completely reckless, and so it's a good thing. So to sum it up, Lightning is an open source project. It's not driven by a specific company. It's not driven by a specific team. It has an RFC-like process to build an implementable specification that you can all check. It is one of the smartest and friendliest development communities in crypto. So obviously it's true for all of them, but it's true for Lightning. It's a really nice place. So come and join us. It's very interesting, and there's no drama in Lightning. It's very focused. Right now you have C Lightning by Blockstream in C, you have LND in Go by Lightning Labs, you have Eclair in Scala by us, and I know there's at least 2 other implementations in progress. You have lots of tools and APIs and applications. There's Satoshi's Place that has been mentioned before, and that is, I thought of including a screenshot of Satoshi's Place. I thought about this for like 2 seconds and decided not to, but it's a very, very interesting concept because it will let you buy 1 pixel. I don't know if you've heard of it, but you can buy 1 pixel for 1 Satoshi. And I'm not talking about you can buy 1,000 pixels for 1,000 Satoshis. It's actually 1 pixel for 1 Satoshi. And 1 Satoshi is 1/100th of a cent. And there's nothing else that will let you send 1/100th of a cent to pay for things online. It's not possible with other cryptos. It's not possible with Visa or MasterCard. It's a really interesting example of what you can do with Lightning that is impossible with anything else. So basically the status is, okay, so it works. We didn't find, no major issues. There are small compatibility issues, but it didn't crash and burn. We didn't have to stop everything for 2 weeks and tell users, sorry, come back later. It's going on pretty well on mainnet. So, and for the issues we have really good long-term solutions. Okay, thank you.